Intro to Docker.
We're still full, but he's going to start. He's going to ram the door.
This is actually Docker. It's a very marketing-friendly containerization is the new virtualization. Really quickly, some of you guys know me. I worked at Puppet Labs for a number of years. I was involved in the Puppet project before that. And I have done a bunch of stuff, sysadmin, engineer, very bad developer. Been involved in open source for about 15 years, and this is my second or third Fosdem. I have a funny accent. This is one of the places where my funny accent is no different from the other funny accents. I'm originally from Australia, but these days I live in the United States. Those of you who also know me know I have a long history of writing technical books, usually for companies that I end up working for. One of the reasons I ended up working for Puppet Labs is I wrote a book about Puppet, and I started writing a book about Docker, and as it turns out I ended up working at Docker. The book will be available in a couple of months when Docker 1.0 comes out, which will sort of be March, April or so. I've decided to wait until we've actually got a solid feature set before I finish it. So, who are you folks here? Is anyone here a developer? Okay. Anyone here a sysadmin? Anyone here both? Or a DevOps person? I can use DevOps doesn't work that way. Oh, and there's Mandy's behind me. Anyone here not one of those things? Anyone here a security person? Anyone here just does everything in the shop because there's no one else? Yeah, okay, Jeff Weiss did that. Jeff also ran those interns. So, I'm going to talk a bit about what Docker is, why it exists, and then some hows. Essentially, Docker is container virtualization. So think about there's two types of virtualization traditionally. There's hypervisor virtualization, where each virtual machine is its own instance, and it lives on top of the whole stack all out lives on top of I guess we call it a thing called a hypervisor, a fake hardware box, I guess. Container virtualization is the other kind of virtualization, operating system virtualization, where essentially every one of your virtualized instances shares the same kernel, shares the same CPU. It's separated by something. In this case, we default to LXC virtualization, so it's separated by namespaces and secrets. So essentially, you get a chunk of the process, a chunk of the CPU, a chunk of the system's resources, all divided up into what I guess we could best describe as little fences around that. So it's not quite as separate as a hypervisor-driven virtualization, but it is very fast and it is very lightweight. So Docker is more than just LXC. Docker is actually an abstraction framework built on top of LXC. So it's built, essentially it says, we want to be able to talk to a container, a thing we think about as a little virtual instance. And we built an API and a bunch of workflow tools around that to allow you to talk to it. It's designed so you can create standard images, we call them images. You can build those images really easy, you can ship them around to different places and you can run them. And it's essentially designed to sort of build once, like build an image that does something and then run in multiple places. And it's as isolated as we think you need, and it's sort of really content agnostic. By that means it doesn't really care where it runs. It wants to be a little bit independent. And a lot of people I've talked to go, but this isn't new. LXC's been around for. They've just released version 1.0 beta 3 or something like that of LXC's been around for a while. Those of you who have grey hair or no hair like me remember things like LPARs, logical partitioning, on platforms like ZOS and AIX, and some people even remember Solaris zones. Yeah, in fact, Sean up the back there, I think talked earlier. Sean is an old Solaris hack. There's a little few of them around. So this isn't a new concept. The idea of operating system virtualization is not new. And we don't claim it's a new thing that there's a lot of people who do, but we've already got stuff. What we claim is new is the way of actually addressing containers and looking at them, building workflow and an API around them. So making it easier, this existing technology easier to use. So, why would I care? I think the key difference that we try and summarize to people is it's virtualization made easier. I'm a big fan of tools like Vagrant. I spent a lot of time living out of VirtualBox. I hate VirtualBox with a deep and abiding passion. I've yet to upgrade VirtualBox where it didn't fuck something on my system. So I also have been a VMware customer on a number of different occasions, and I've received a number of VMware invoices, usually with large numbers of zeros at the back of them. I look at this as a much lighter and cheaper way of deploying virtualization. And it's a little bit. I won't call it anti-DevOps. It's certainly not. But it has a moment where it's sort of like it is trying to do a little bit of sort of isolation, where the stuff that inside the container, the developers care about inside the container, and the application operations people care about the operation systems and admin people care about what's outside the container. So Luke Kinese, who's around at the conference somewhere, but also famous for having written Puppet, many years ago wrote a blog post called about golden images. And those of you who've been sysadmins for a while will remember the period of time where golden images existed. Essentially, it was you had a DVD and it had like a long string of numbers on it, usually like 2003-12 V2 RRR 777 release date. And that DVD was the standard operating image for your environment. Maybe it was back in the day, it was a RHEL 3 box or something. And you used really cool tools like Norton Ghost. Anyone know Norton Ghost? And no, Sean's going to put his hand up, and there's probably maybe only other person in the room. There's a handful of people. And you basically shipped around this image and you built your service from it. And of course, what happens is you wanted to upgrade the image, then you needed to burn a new DVD, and you need to ship the DVD around. And guess what happens? It's very hard to re-image a server like that. It is a non-trivial problem. It's like, I can't rebuild this. Configuration is drifted. I can no longer install, and I end up doing things like getting on a machine, manually upgrading packages, manually making configuration changes. And this was called the golden image problem. You end up having one single image that was in fact instantiated across multiple different forms across your enterprise. And Puppet came out of that, which is essentially you wanted to actually be able to have a base operating system, and you wanted to do state management on top of this. You wanted to manage various different things. The issue that really struggled and why things like Puppet and Chef became quite interesting was that this was a much faster way of doing that configuration management. Docker being very lightweight and very fast, building a new image is a matter of minutes. And it's a very simple process. It's a very simple DSL, and I'll go into that articulates how you build an image. And then spawning a container from an image is like this. So you don't have that sort of couple of minutes of creating a new image or installing a new operating system or following some build steps. You just have you go to Docker run and you have a new container based on an image. So it sort of overcomes some of the problems we have with that golden image workflow, which is that you have that time period where it takes to build and image deploy. If it's very cheap for you to do that, why wouldn't you throw away the original build and build from scratch? I'll talk a bit later about why some ways we allow you to sort of do this in the closer. This is sort of my summary of why developers care. And I'm not going to go through every single dot point, but I do a lot of, we have a lot of people who are particularly interested in sort of continuous integration, continuous deployment going forward. So their code starts on, in a Git checkout on their laptop. They do a bunch of development. If they're slightly more advanced developers or developers with a clue, maybe they've got a tool like Vagrant and they have a local machine running, or they have an instance running out, in an ESX cluster or on Amazon where they run their tests, or they test that the code actually works. And then that code gets promoted up to another environment. Maybe Jenkins gets run at that point, some test suite stuff, some artifacts get built, and war files get shoved into Artifactory and all that sort of stuff. That sort of life cycle stuff is where we're seeing sort of Docker's initial bread and butter, which is that you can very cheaply and very simply create a runtime build environment that's isolated from your desktop or isolated from your environment, and you can tweak that environment and change it really quickly. So instead of having to wait for, like Vagrant, whilst extremely fast, it does take a couple of minutes to run up an instance, whereas Docker Run, very simple, part of the process, very easy to recreate the container. The other piece of magic we introduced is a concept of an image registry. So essentially what happens is you can create a new image, like I would like to have application 1's image, and I can push that new image up to a registry, and then all of the developers in my environment who have access to the registry can now pull the new image down. I don't have to ship. I worked in a company that shipped new Vagrant box images around on USB keys, which I was like, you people are mad, but people do it. You don't have to wait to upload a new 100 meg image. You get a very fast, simple process. And the reason a lot of developers find this really interesting is that you can actually run, because containers are so lightweight, and I'll talk a little bit about how we do that lightweight aspect of the storage is that it's very easy to maintain multiple operating environments. So I can maintain, at a very cheap sort of rate, I can maintain a version of 6 different versions of Rails if I'm doing a Rails development. Or I can maintain Python 2 and Python 3 and separate containers. Operations care about containers for the similar reasons that people care about configuration management, which is that it makes the lifecycle more efficient. It's really easy to introspect on the container to say what state the container is and what it looks like. They're very easily manageable and very easy to make change about. And they have the same advantages that configuration management provides. Essentially, the environment you know your developer is working in locally, you know they're using this particular image, you know what makes up that image, and you know that if you push that image through the various environments, from the dev, test, production environments, that you're running the same bit of code, which provides you that consistency you get with knowing that the same Puppet manifest built the test environment, the same Puppet manifest the production environment. They support a reasonably clean segregation of duties, and they essentially, for a lot of cases, they provide much faster workflow. So I talked a bit before about virtual machines in the cloud, and why the sort of Docker is attractive. I talked a bit about the speed of things, but there's a couple of other aspects of it too. One is that containers are relatively portable. The container images are easy to move around. And the way they're easy to move around and portable is because we create them with a layered union file system. So what happens is that each image is built with a set of instructions that say, install this, usually our base image is at the bottom of Docker. It says use a Ubuntu 12.04 operating system. And then it says, build another, every instruction I give you, build another union layer on top of that container. So what happens is that I end up with a single image, for example, like a Ubuntu 12.04 image, and I want to build on top of it. So I go, I would like to install Rails. So I run, gen install Rails, or I do an apt-get install Rails, depending on my preference. If I then want to make another change, for example, I want to create a new image which has a new version of Rails, I don't need to change that base image. All I need to do is make the change to the instruction on top of it, so the single layer is changed. So instead of having to change, as you would with a very good box rebuild and a 600 meg box file, I only have to change the one layer. So that one step is the only thing I need to change, which means that it's very fast and very quick to rebuild those images. The other thing is, because it's so lightweight, we get a far higher density. So we've got a number of customers for whom the number of images, the number of virtual machine instances they have, they can get double the number of containers onto a single box. And if you're talking to a CTO or a CIO about that, they're going to be pretty happy with the idea of the fact that they can cut their virtualization. And so cheap wins quite a lot of the time. The technology stack is really simple. It runs on most Linux distributions. The idea behind the initial Docker release was it supported LXC, which runs most places reasonably healthily. It's going to be included in Red Hat, and the Red Hat Enterprise Linux 7 release will have Docker Run natively, so you'll be able to yum install Docker natively supported by Red Hat. Similarly, in Debian, the next Debian release and the next Ubuntu LTS release will also have native Docker support. It relies heavily currently on namespaces and secrets as well. Those are familiar with that. It's a way of providing segregation of processes and resources on the operating system. And underneath the layered file system, talk about it supports things like device mappers, provisioning model, and AMFS, which is a union file system. But the really interesting thing about the next one is the sort of major production feature release of 1.0 is it's going to be a plugin. So if you like Solaris zones, then you can run Solaris zones underneath that as another execution engine. So essentially get the benefits of the Docker API and the workflow, this sort of very fast build process, and the API associated with that. But you can run LXC or Zen or KVM. Currently our base plugin, which we're using for testing, is a simple Chroot jail, which means you can then start to run on a bunch of different platforms. BSD is the first one we've seen. Somebody's actually doing a Google Jails implementation right now for BSD, which you can start to think about some things you can do, like networking and stuff like that, by putting that sort of running on firewalls and switches. But we're also starting to see support for, there's some discussion about support for Solaris, OSX, and a bunch of other sort of platforms. this is, I guess, a visual representation of how the model works. Essentially, it's a very simple kernel. Your kernel, you have the various bits and pieces, cgroups, namespaces, device mapper, boot file system, have a base image, like for example, I said a 12.4 image, and then each of these layers is another image built on top. And I'll talk about each of those components really quickly. This is what we call a Docker file, a very originally named configuration file. It basically contains a set of instructions for building one of those base, one of those contains from images from. You say it from Ubuntu, so you say this is our base image. This might be, say, Ubuntu 12.04. This image is available. We have a public registry of images, which can contain things like a minimal build of Fedora, a minimal build of Ubuntu, a minimal build of a bunch of other platforms. I specified bit information. This is I'm the maintainer of it, and then I have a series of instructions. In this case, this image creates an Apache 2 image. So I say I want to install Apache. I want to set some environment variables. I want to say, when I run a container from this, I want to set up the networking to make sure that port 80 is available. And then I want to say, when the container that I build from this image is run, I want to run some default commands. This is essentially like a boot up script, like a little init for the container. So let's say I'm a developer and this is going to be, or a sysadmin, this is going to be how we build our baseline Apache 2 containers. I create this image, I build it, and the build process essentially takes that base image, downloads it, and then runs those commands and builds each layer on top, and basically publishes the end of it. Here's my image, and it gives you a little char that says this is the version of the image. And I can give it an alias. Here I'm giving it a namespace alias, saying this is my image, this is my namespace, and this is my Apache 2 image. And if you have a look on our index.docker.io site, you'll see this actually image is available there. I then push that image upstream, so I push that image to a registry. We make a public registry available, or you can also run the registry, it's open source, you run privately inside behind your firewall. And from this point in time, anyone else can then take that image and do something with it. So in this case, I'm going to say, I'm now a developer, and I've got an email saying there's a new version of the Apache image available. So I say, I'm going to run Docker. I'm going to run it in its demonized mode, so I'm going to create a demonized container. I say, I want to make sure port 80 is open. What happens is on your system, it says, open up port 80 and assign me a random port, like a random high-level port on my local machine. So I can run multiple containers. I'm then mounting my application. So this literally mounts the application as a file system inside the container. This means that I can do things like I have my web application, or I have my database, or I have my data itself in some sort of storage system in NFS. We're going to support a bunch of other storage platforms shortly, and I can make whatever changes I want there, and the container runs on top of it. And it treats it very much like a shared file system or a shared folder, so you can think about it in the virtualization world. And then I've told it this is the image I want to run. It takes about a sub-second performance to launch the container from here. And then this is now available. I have another slide. I was managed to delete last night. But essentially, from here, I can then just I can identify which, I'll get a routine saying what port is available. I can then point my browser at that port. I can make all my changes to my application, hit refresh, to watch my web application be developed underneath it, and watch the database run. We've got a bunch of, we're seeing a bunch of really interesting use cases for Docker. Guilt in New York, who are a fashion startup, a very service-oriented architecture company. They run everything in microservices. They're replacing their entire execution environment with microservices running Docker. So they have, they're an Erlang Scala shop, and they have, Redis and React and a bunch of other services. They're just going to put each of those in separate containers, link all of those containers together in build environments, and use that as their service-oriented architecture. We're seeing lots of people doing this sort of local development and sort of Jenkins development. A good example is there's some stuff published recently about how to use Docker as an execution engine for Jenkins. So if you imagine, like, it takes a couple of minutes to run up a virtual machine, or if you're using EC2, it takes a few minutes to create an EC2 instance to run your tests on. In this model, sub-second availability for a machine. Incredibly easy to rebuild that image, so every time you upgrade the image, build a new baseline image, you can then recreate that and then run your tests on top of it, build spawn containers from that. We've seen people whose previously their provisioning time in Jenkins might be 5 to 10 minutes to actually get the boxes running. you get a clean, fresh build of the instance in a matter of seconds. And from here was a bunch of other things we're looking at, which is integration with things like configuration management, orchestration. If you have lots of containers running in multiple data centers, how we share the talk about that. You see some things published in the last couple of weeks about how you use various tools like Zookeeper and DCD and things like that to actually share configuration information across multiple Docker environments. Questions? This is one of those things where I keep putting up these signs in the documentation saying "Here be dragons." I think we're just about to release 1.8 and it's pretty stable. The API is reasonably solid. I'd be very surprised if it changed dramatically between now and 1.0. My sort of don't use it production warning is largely around supportability. Like I can't provide you with any support at the moment. But Red Hat is replacing its container model for OpenShift with Docker. Docker is currently the open stack sort of preferred flavor of containers. Gives you a good indication of where we're going. And the largest install I know is Baidu in China and Yandex in Russia. And they're both running. Baidu has a Google App Engine-like product that uses Docker. They have tens of thousands of containers, and Yandex has similar, I think it's sort of 40,000 containers. So people are using it in production and go, my biggest concern is the API stability, and that's heading towards I think that's more a portability thing. So it's like if you look at sort of execution piece, you want to have their workflow and that same API to be able to address these multiple virtualization platforms. And several people have tried to do this, like Dave Lodecourt's Delta Cloud product, things like that. It's essentially designed to abstract away the differences between virtualization products, say with Fold and tools like that. They've not been hugely successful because I don't think they address the workflow piece of it. They provide an API, but they don't provide a mechanism for the life cycle of the virtual machine. Particularly, they don't provide mechanisms to recognize that virtual machines have a much faster lifecycle. So that's the advantage of using Docker with different execution engines. As you can say, I can run locally on LXC, and we have a little tool to Docker which creates a little local Docker daemon on OS X and allows you to do local development. I can then take that exact same image, built the same way, and I can promote it into a VMware environment, or promote it into a Zen environment, or KVM environment, promote it nice into whatever it happens to be. And it's the workflow in there. I think it comes down to the sort of classic, I think the containers are the LXC is a reasonably solid technology in most cases, like it's a little bit, but I would say any sort of fast changing data you probably should be mounting into a container. Any sort of static, like there are thousands of stateless things. Like if you are doing moving a web front end with Docker in a way where it's actually serving static content, back to an app server or middleware, then yeah, just include the content. If it's a standalone microservice, like some sort of API endpoint, something like that, a Scala endpoint, something like that, then yeah, just include that inside the container because you don't need to worry about it's all stateless. And it calls out. We also have a concept of linking, so you can link containers together with essentially I can say, here's a container, I want to link to this other container that runs my database, and it creates an encrypted tunnel between the two containers, and it doesn't expose any ports. It allows you to say, address using inside your application. If you want to consume data from a database or store something over here, then go after that and use that linkage. That's pretty basic at the moment, but we'll see a bunch more use. For the moment, yeah, I think because there's only one form of, we only do mount currently, that's all we do. So at the moment, that's probably the simplistic answer. When we have more storage options, then yeah, there might be a bit different. when we can directly address different obstacles.
Before and after machine. So how do you mitigate those anti-DevOps? Golden images.
So what's that, sorry?
The golden image.
So my argument is that the golden images exist because the technology wasn't fast enough to make the change, and that in a lot of the use cases, that now that you can actually very quickly recreate the image and very quickly spawn containers from that image, the golden image problem is not as large as it used to be. I think it still exists, and you can still end up with multiple hierarchies of images, and you can get yourself in any rabbit hole you like. Sysadmins are excellent at this. Like, we all know this, right? Somebody tweeted earlier, like, Bash is still a primary tool for DevOps people. I know whether they're being sarcastic or not, but it's pretty true. There's still a lot of hacky / scripty stuff. So I look at this workflow as, at the moment there's a certain percentage of tasks you would do that Docker makes a lot of sense for in its current build, and as we sort of expand, that may grow or change. We may get more use cases out of it. Several people have posted using Docker with Chef, examples of how you build a Chef-powered Docker image and then run your cookbooks on top of that. I published a blog post recently about doing the same thing with Puppet and Puppet modules. I don't know where it will go. I think there's a huge expanse of use cases. I'm certainly not saying, particularly our financial population, I'm certainly not saying you should throw your Puppet manifests away. But I think in certain cases where the workflow is much faster, I would seriously look at whether you would use Puppet further. I guess we could describe as upstream, and then downstream we would be building images and running containers from there. There's a bunch of different ways you can slice it. I don't think the future is yet even a distributed. So there's a couple of very at the moment these are a couple of the APIs that may change a little bit, but there's an events API that essentially says you can basically poke in and see the logs, it's the standard input and output logs. You can also poke in and inspect the container, see a bunch of running metrics. Like you can also see events that happen inside the container. And we're going to build a stronger introspection API over the top of that. So you can do things like, if you see this event inside the container, then trigger a hook. Here's a hook, and hang off that hook. Or here's an API call you should make. Or if I want to be able to manipulate the container in that sort of way. So that's something that'll become with the long-term release. Oh, okay, fair enough. No, I'm probably in a minority at Docker actually. I think most of I don't know whether most people know, but Solomon and about 50-60% of the development team are French. And there's lots of Linux desktops. I'm a hipster. I live in Brooklyn, so I have to have a Mac. And I have to explain to people what Linux is, but everyone recognizes the sort of box. So we have two things to mitigate that. So the image has a concept of what we call trusted builds. So trusted builds are essentially someone's published an image, and it's linked via to a GitHub repo, and you have to actually link to a GitHub account in the index. And essentially it says, this is the repository this came from, and here is the Docker file that builds it. So you can introspect on that and see that this build came from this repository at this commit using this particular Docker file. And the second thing we're adding to the index on top of that is we're adding crypto. So essentially you'll be able to sign images. So what we're looking at for the moment, like Red Hat, for example, will take their base their base certificates, and they will sign their JBoss images, or they'll sign each OpenShift container will be signed, so it has provenance back to all the way up to a chain of trust. So say, this comes from that particular developer. I will keep talking until Walter tells me to shut up, so...
Yeah, 5 more minutes.
Okay, I've eliminated all of the questions. Yeah, so CoreOS is, so some of you guys might know Alex Bowlby, who did cloud, what was it called? It was a cloud metrics company that Rackspace bought. He's got a new venture called CoreOS, and essentially it's an operating system built around Docker. So So essentially, it's an operating system replacement or just enough operating system that allows you to spawn Docker containers. And it's really designed at the moment, I think. I can't speak for them too much, but it's really designed to sort of, if you're a PaaS or something like that, and you want to run an operating system that is tuned and built to just spawn high density containers. I think the big challenge with that will be that it is an operating system replacement, and if you're doing something that's not PaaS-like, then it's kind of, I think the utility of it, if you're a RHEL customer, the idea of throwing away your RHEL and replacing anything outside of a particular opposite use case. They have also released a product called ETCD, which is like Zookeeper except it's usable. I love Zookeeper, but it's a pain in the ass to set up. And ETCD is so much nicer. It's what I would have wished for when I was operating sort of production systems. Cool. All right, thank you very much, everyone. Really appreciate it.